Hassan, first of all, I just wanted to thank you so much for taking time out of your very busy schedule to talk with me today. I am super excited to do an employee spotlight with you based on your current work that you do for SSAI. My first question I wanted to ask you was, what drew you to SSAI, and how does the company's mission resonate with you personally?
Hello, Jason. First, I'm really excited speaking about my career here at SSAI and share my professional experience. I feel honored to be a part of this spotlight. So first, I should mention that growing up, my Moroccan heritage instilled me a deep appreciation of perseverance, adaptability, and sense of community. And I carried those values with me when I moved to the USA, coming from France, where I got my PhD in remote sensing. And so I came to the US in 1996, thinking about pursuing my career here at SSAI and also within the NASA environment. I truly think that the Moroccan values continue to shape how I approach work at SSAI and everywhere else. So when I came to the US, I landed at the University of Maryland as a visitor scientist, where I took a research scientist position, supporting multiple NASA Earth observation missions, such as Landsat, MODIS, Aviator. Then in 2000, I joined SSAI company, where I had the privilege to work on a cutting-edge Earth observation mission called JPSS, and ensuring that all the calibration, quality, the processing efforts support the NASA science goals. And beyond the technical side, I found that my background helps me bring unique perspective to collaboration, coming from a culture that values the hospitality, dialogue. I strive to build strong teamwork and communication both within SSAI and in partnership with NASA. It's kind of a blending of technical expertise and cultural values that makes my working at SSAI so meaningful to me. I should mention also that at SSAI, I've been really fortunate to work with incredible scientists, engineers that shares common goal, leveraging science and technology to solve real-world challenges, whether it's improving satellites calibration, enhancing the data accuracy, supporting NASA missions. I see our work as part of the large effort to advance our understanding of the planet and contribute to our society.
Wow, that's truly awesome, Hassan. I'm so grateful to hear that you've had such an incredible experience at, SSAI. And I had no idea, by the way, that you were from Morocco. That's something brand new to me.
There we go. Welcome to Morocco.
Yeah. But, I'm so thrilled to hear, with your heritage and, where you came from, that it really resonated with you and you were able to bring that positive energy here at SSAI. So I definitely learned something new with that. So I really appreciate you diving deeper into that. So, and Hassan, I wanted to transition over to my next question that I had for you. SSAI has been at the forefront, as you mentioned, of supporting NASA's Science Exploration Directorate through the development, testing, and calibration of critical space sensors. From your experience overseeing these projects, what are some of the most significant advancements in space instrument technology that you've been a part of, and how have they impacted Earth and space science research?
Yeah, that's a good question. One of the most impactful projects I worked on during my PhD was developing a space-based food early warning system for the African Sahel. The idea was to use satellite imaging time series combined with sophisticated models that can be used to analyze the agricultural crop conditions and predict food shortage long before it becomes a crisis. So what we did is that we developed this system that provides critical data to the local governments and international aid organizations, and we could mobilize resources in time to prevent starvation and save lives. Seeing how space technology could have direct impact on reinforcing on the societal situations that could hamper all the population, it's just reinforced my commitment to Earth observation and remote sensing sciences. The other major NASA project I supported for many years is the SUMI NPOS Preparatory Project, or SNPP, which is back then was considered as next generation of Earth observations. This is a follow-on mission to the well-known EOS missions, Terra, Aqua, and Aura. And NPP mission is part of a large program called the Joint Polar Satellite System, JPSS, which is a constellation of 5 missions. NPP was the first mission of JPSS program, which was launched in 2011. And my role was to lead the development of the calibration and validation plan for the mission, which carries 5 instruments: VIRS, CRIS, ATMS, AMS, and CIRS. All are major instruments for weather forecasting research. The instruments were developed with state-of-the-art technologies at that time, and my responsibilities have been to cover all the full life cycle of the calibration validation activities, ensuring that high quality of the data, reliability of the satellites data products, and work directly with various science teams to define the calibration processes and validation requirements, so we can come up with the CAVAL plan that covers both pre-launch and post-launch phases of the NPP mission. And this includes, of course, all developments of testing activities at the sensor vendor, the data sets needed from the calibration sites located around the world, and planning for field experiments that will allow us to acquire useful data for land, ocean, atmospheric data products validation. I was also designated as the NASA representative for VIRS instrument calibration and characterization, playing important role for facilitating the communication between the science teams on one side and the engineering teams on the other side. And I really think I enjoyed very much this role. I felt that my effort was crucial in the communication of the design and the performance issues to the science teams. And this was very important because it allowed us to minimize all risks that could be involved in terms of degrading the instrument performance once on orbit. And also it helps us cost saving because we are working on the issues before ahead of time in the instrument development, and which allow us to provide this information to the science team, coordinate with the science team, and come up with the fixes right away. And so before we can move on to the next step of the program. So right now, there are 3 JPSS missions on orbit: SNPP, JPSS-1, which was renamed to NOAA-20, JPSS-2, which was renamed to NOAA-21, with 2 more missions to launch. We are working on right now, so to get them ready for launch in the next few years. And I really feel good about contributing to these crucial missions, especially the VIRS instruments, which is providing really highly accurate and important data for dozens of environmental and societal applications worldwide.
Wow, that's truly fascinating, Hassan. And I really appreciate you breaking down some of the projects that you have been involved with, because some of them, I've heard of them, but I didn't know too much about them before. So it's just very fascinating. It's very incredible. And based on the 2 upcoming missions that are coming up, we're definitely very excited to highlight, more about that as well. So we will definitely make sure to, keep our audience staying tuned, and we'll definitely make sure to do some additional spotlights with that. Do you know when those missions are going to be happening or launching?
Yes, JPSS-4 is going to be launched first in 2027, sometime in mid-2027, basically in 2 years, about 2 years. JPSS-3 is going to be launched in 2032, 5 years later. So yeah, it's almost every 5 years. So it's we are covered for the next 8 years or so.
Wow, we'll definitely keep in touch, and we'll make sure to highlight this launch, and we'll make sure to keep everybody informed of these missions. This is just super
Absolutely.
exciting. So thank you so much, Hassan, for further talking about that. Hassan, my final question I wanted to ask you was, with your extensive background, as you have just described, in leading large-scale NASA and NOAA projects, what are some of the key challenges in Space Center calibration and validation, and how does SSAI's expertise help ensure the highest standards of accuracy and reliability for these mission-critical instruments?
Yeah, good question again. Okay, well, we all agree that the calibration and validation of spaceborne sensors are essential to ensure high quality, reliable, and scientific integrity in the Earth observations. However, a number of Earth observations missions continue to grow, especially in the commercial sector. We face increasing complex challenges, particularly in the data volume, data fusion, and the AI-driven automation. So I think these are the three major challenges I foresee that will drive the future technologies, and we fully understand the need to develop solutions and expertise in these areas as we can play a critical role. So as I said, with an increase in Earth observation missions in orbit, we are generating unprecedented volume of data, reaching petabyte scale of data. This is humongous. This puts significant pressure on our data processing system, disk storage, and computational infrastructure. And of course, our traditional methodologies for handling calibration and validations are really struggling to keep up with the pace of this exponential growth. The data fusion is another challenge, and the current state-of-the-art Earth observation science, for example, integration of optical, infrared, microwave, and LiDAR observations will definitely help obtain more comprehensive understanding of the environmental processes. However, achieving the consistent cross-calibration between these instruments is very difficult because of differences in the configuration, and each instrument has its own specificity about the spectral, the spatial, and the temporal characteristics, and this remains a major challenge for the science community. Again, the large volume of data and complexity of these data sets make the calibration and validation method time-consuming, resource-intensive, and we truly understand that the integration of the AI machine learning workflow requires new methodologies, currently under development, and extensive training data sets and robust validation to ensure scientific accuracy. So in addition to this, the volume of Earth observation data sets increasing with more satellites coming into orbit, computing resources are increasingly inadequate for efficient processing. And here comes the cloud computing solutions, which provide scalable infrastructure for storing the processing data and analyzing large Earth observation system data sets in almost real time, and enabling more efficient calibration validation operations. Again, the main issue here is now how we can transition the traditional system that we are using currently into the cloud, and at the same time keeping the accuracy of the data and the security and the accessibility. So all of this still needs a lot of work, and we are just at the beginning of the path. So I think SSAI is trying to solve these challenges, looking into cloud-based operation solutions to manage more efficiently these large-scale Earth observation systems or data sets, and exploring machine learning algorithms to support the CalVal efforts, and to ensure that next generation of spaceborne instruments deliver the most accurate, impactful scientific data sets. So I think these activities are directly contributing to advancing our missions and its ability to provide high quality environmental data and supporting weather forecasting, disasters response efforts, and of course, with the main goal of enhancing our understanding of the Earth systems and, of course, enhancing the life on our planet.
Wow, Hassan, I think you highlighted and touched on multiple different great points there. I really appreciate you just breaking down, how our expertise is helping to ensure the highest standards of accuracy and reliability for, these mission critical instruments, and especially with data too, because I know one of the big things that we're doing as well, we definitely want to tailor it so that way many different kinds of audiences can understand it, because everybody learns in different ways and at different rates. So I know I'm definitely someone who learns best visually, for example. So definitely in relation to all of the data that is collected and is gathered, it's definitely very cool to see how it's translated and broken down in a way that helps people to understand, why is this important? How does this relate to my everyday life? So, so I really appreciate you, Hassan, breaking that down, and your work is just absolutely fascinating. So
thank you for giving me the opportunity to showcase what we are doing at SSAI and what we are doing for our planet Earth. Thank you.
Absolutely. And Hassan, I just wanted to emphasize to you as well, you are truly a rock star at SSAI who is really making an impact and a difference globally. And everybody around the world is going to continue to be fascinated by the great work that you and your team do. So, so please definitely keep us informed about continued enhancements and discoveries that are made, and about these 2 upcoming missions that we have. And we can't wait to highlight it.
Absolutely. Anytime. Thank you.